Here we're looking at question 3 from the 2022 AP Calculus AB section. This is actually from the calculator not allowed section, but they continue the same numbering. So this is the first question on the calculator not allowed section, but question 3 overall in the free response section. So let's take a look at what we've got here. The first thing that I do on any problem that has a graph on it on the AP Calc test is I want to make sure I know what this is the graph of. And so what I see here is that we have the graph of f prime. We're looking at the graph of the derivative up top there. And then they're telling us that we've got at least one bit of information about the original function. F of 4 is equal to 3. And then the shapes that we're looking at up above consist of a semicircle and two line segments as shown in the figure. So from there, what we would end up wanting to do is kind of answering whatever questions they give us. This is just going to talk about part A here in this video. So on this one, we want to find f of 0 and f of 5. So to do that, that's getting back to the original function. So I've got a derivative graph up above, I've got a point off the original function, and so what that leads us to is we're probably going to want to use an antiderivative, an integral to get back there, and we're probably going to want to use a definite integral. So if I take a look at this, and we're just going to find one value at a time. So the first value we're going to go after is going to be f of 0 right now. So using f of 0 with the one point that I know for sure is on that original function, I can set up an integral that's going to find that. So we would say this is the integral from a lower bound of 0, because that's the x value that I'm worried about here on f of 0, to an upper bound of 4, because that's the x value from the point I was given, of my derivative, that is going to equal, we don't need to do that antiderivative yet, but what we want to see is what the conclusion would have been. If I undo this, this would have been the original function f of x evaluated from x equals 0 to x equals 4. And so from there, we would have been able to do what I just call the top minus bottom game. So you would have plugged your top value in and subtracted off the bottom value plugged in. So the top value would have been 4. So we would have said f of 4 minus the bottom value, f of 0. And what does that have to equal? Well, this is where they really want us to kind of be coming at this from a geometry point of view. What we know is starting here, remember that we're taking the antiderivative of our derivative. So starting here at 0 and ending here at 4, that's this shape right here, which they told us is a semicircle. And so we can say that that's going to be equal to 1/2 pi r squared, because it's half of a circle, so it's half of our pi r squared formula. What's the radius here? Well, if that's the center of my circle, then the radius is going to be this distance here. So we have a radius of 2. So as we come through and start putting these pieces together, we're just going to be solving this equation here now to get f of 0, which is what we're looking for. So let's start putting in the values we know. So f of 4 we know was 3, minus f of 0 is what we're looking for, and that's going to equal 1/2 pi, and then our radius in this situation we found was 2 squared. And the thing to be careful of here is notice that this half is down below the x-axis. So this area is going to be negative when all is said and done. That's our formula, but we're going to make it negative because it's below the x-axis. Remember, area above the x-axis is considered positive area. Area below the x-axis is considered negative area. So then we'll keep solving this thing out. We get 3 minus f of 0 is equal to negative 1/2 pi, and then 2 squared would be 4. Keep rocking our algebra here step by step. We get 3 minus f of 0 would be negative 1/2 times 4 is going to get us negative 2 pi. And now we're just going to move everybody around. We want to get f of 0 by itself. So we're going to add f of 0 over to this side to make it positive, and then we'll add the 2 pi over to the other side to get it that f of 0 by itself. So 3 plus 2 pi is what we get on the left, and that's going to equal f of 0. So right now we found our first answer. Our f of 0 is going to equal 3 plus 2 pi. We don't have a calculator, so that's as far as we can take it. Now what we need to do is kind of play a very similar game, except this time we're going to use f of 5 right here. And we'll still use our f of 4. So this time we're going to be setting up the integral from lower bound of 4 to upper bound of 5 of f prime of x dx, which we know what we're going to get out here. This is going to be f of x, the original function, evaluated from x equals 4 to x equals 5. And again, you play your top minus bottom game. So f of 5 minus f of 4, and that has to equal this little bit right here. And so when you look at that, you'd say to yourself, dang, that looks like it's hitting right there at 1, right? So this is the area of a triangle. So the area of a triangle is 1/2 base times height. Popping into this formula, our base is going to be this gap right here. We have a base of 1. And then our height is going to be this gap right here. That's also going to be a height of 1. So then we end up with that. And then we have f of 5 minus, and then f of 4, again, we know that value. That was given to us to start with. The f of 4 is 3. And we're just going to solve this now to get f of 5 by itself. So we go ahead and clean up that right-hand side. We get f of 5 minus 3 equals 1/2 times 1 times 1 is going to get us 1/2. And then we would go ahead, final move here, and just add that 3 over to the other side. And we end up with f of 5 equals 3 plus 1/2. You could convert that into a single fraction. This would be 3/2 would be 6/2 plus 1/2. So that's going to equal 7/2. And so f of 5 is equal to 7/2. From there, what you're going to do is get, where we get our points on this one. This is 3 points here out of our total 9 points on this problem. We would get 1 point for getting our 2 integrals set up properly. And then we're going to get a point each for our 2 answers. So then we're going to get 1 point here for getting that answer, and we would get 1 point here for getting that answer, for a total of 3 points on part A of question 3. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.